Well, now let's talk about the graph secant of x. So we're interested in finding out what does it look like when we graph the function y equals secant of x. And again, kind of like our sine function, we said that, or our cosecant function, secant is the reciprocal of cosine. So we can use the cosine function to help us guide what the actual function of the secant of x is going to look like. So let's start with what we know. Y equals cosine of x. And over a basic period, we know that if x and cosine of x, we're getting the x and y values right here. It's my impression of a straight line. Just use your imagination. 0, pi over 2, pi, 3 pi over 2, and 2 pi are the key points within one full cycle of the cosine of x function. And at 0, the cosine of x goes to 1. Pi over 2, we go to 0. Pi, we go to negative 1. 3 pi over 2, we go back to 0. And 2 pi, we go back to 1. So if we're looking at the cosine of x function, again, let's go ahead and sketch this over 0 to 2 pi and maybe a little bit further if we can get it. So I'll mark off my axis, just choosing every other hash mark here to represent one division of pi over 2. So here's pi, here's 2 pi, here's 3 pi, and we'll make this y equals 1 here, and we'll make this y equals negative 1 here. So our cosine function over the interval from 0 to 2 pi is going to start at 1. It's going to give us 0 at pi over 2, and it'll give us negative 1 at pi. It'll give us 0 at 3 pi over 2, and then we go back to 2 pi. And if we were to continue this pattern, we'd get negative 1 at 3 pi. We'd be 0 in between each of these key points right here. We'd be back to 0 over here at negative pi over 2. And our function would take this shape, which looks an awful lot like the other shape that the sine function took, only shifted pi over 2 out of phase. You like that? Pi over 2 out of phase. I like that. Pi over 2 out of phase. Sounds kind of neat. All right, so this is my cosine function here in purple. What do I do with the secant? Well, secant of x, remember, is going to be the reciprocal. So secant of x at 0 will also be 1. Secant of pi over 2, however, is going to be undefined. Then at pi, we're going to get negative 1, just like cosine would. We're going to get undefined again at 3 pi over 2, and then we're going to go back to positive 1. And so we're going to find vertical asymptotes anywhere where this cosine of x graph crosses the x-axis. So let's try it out right here. If we're going to put this in, we're going to find that, for example, at x equals negative pi over 2, we're going to get a vertical asymptote. X equals 0, no, that's defined right there. But pi over 2, here's another vertical asymptote. X equals pi over 2 is a vertical asymptote. Let's see, 3 pi over 2, right over here, right between pi and 2 pi, we get another vertical asymptote. And then here we are at 5 pi over 2, which is between 2 pi and 3 pi. It's like saying 2.5 pi, right? 5 pi over 2. The next one would be over here at 7 pi over 2. And we could keep going this way, but all right, I think I've named enough. So now you know kind of what's going to happen. Just like with our sine function, we took the reciprocals to get cosecant. In the secant function, we're going to take the reciprocal of our cosines. So for example, here at the value of pi over 3, we would get cosine equal to 1/2, and so we're going to get secant of pi over 3 to equal 2. Same thing at negative pi over 3, positive 2, and this graph is going to come down along the vertical asymptotes, pass through the point 0, 1, then go back up along its vertical asymptote, Similarly, in this, between our asymptotes pi over 2 and 3 pi over 2, if we were to go to 2 pi over 3, we would get negative 1/2 for cosine. So we're going to get negative 2 for secant. And likewise over here, let's see, this would be 4 pi over 3. So we're going to get negative 2 right there. And our cosine function will pass between these two vertical asymptotes. Look like an upside down U here, right? And then we would get the same shape repeated here over this interval from 0 to 2 pi. And then here from 5 pi over 2 to 7 pi over 2, and so on. So this is the shape that's going to repeat itself over and over again. Now, as far as identifying the asymptotes, right, we see that we're going with these odd multiples of pi over 2, so we're going to say, well, odd multiples, 2n plus 1 multiples, where n is an integer, of pi over 2 are the location of the vertical asymptotes of our secant function. And you see that conforms to our domain that we talked about earlier, the domain being the set of all x such that x is not equal to an odd multiple of pi over 2, where n is in the set of integers. And our range, by the way, also conforms to what we said earlier, and you can see that the graph here in black goes from negative infinity to negative 1, does not include anything between negative 1 and positive 1, and goes from positive 1 to infinity. So you can see that this conforms to everything we've said before.